Hello and welcome to my series of tutorials for AutoCAD. These are aimed at the UK based arboriculturist who needs to simply update a supplied site plan with their own tree data and produce tree constraints and tree protection plans, etc. We're only going to cover in these videos the basics you need to do that job. But unfortunately this first video does need to cover all the fundamentals and technical side of AutoCAD, so may well be a bit boring and probably cause your eyes to glaze over later on. So AutoCAD, highly accurate drawing program, vector based, which means you can position drawing items and then move them around and manipulate them. Uses a DWG DXF file formats. DWG is the principal, the DXF is an interchangeable one for use with other CAD drawings and programs. So for this demonstration I'm using a demo CAD which I knocked up a long time ago. One of the problems with just starting out with AutoCAD is you don't have anything to sort of practice on and play around with. So you can download this drawing from my website. I've put the link in the description for this video, and feel free to download them and do with them as you wish. We'll start with just the mouse. It's important that you've got a mouse to use because you need the mouse wheel. Trying to do this with a laptop with just say a touchpad I think would be pretty difficult. But the mouse wheel, you just move the wheel front and back and it zooms in. Press the mouse wheel and you can pan. And that's really important for fast work. So let's just describe the screen layout quickly. We've got, and we're on the home screen. You've got your drawing functions, your modification functions, and a mixture of drawing and modification. You've got some drafting aids down the bottom here which are sort of switchable or selectable, and down here we've got the model and layout tabs. So let's start with the model and layouts. Model is where you do your drawing, where you create your drawing and modify it. The layouts or paper space are intended for arranging your sheet for printing and producing a PDF. It's not intended to carry out any sort of actual work, if you like. So your layout will have a viewport on it. This is a viewport. And the viewport is a window onto model space. And what you would do, you would have your key and your logo and your name, etc., all down in perhaps little boxes like this. And these will be filled with text and things. And you would show in your viewport the part of the drawing you want to see, and you would scale it, and you would put a scale bar on and a north pointer, etc., etc. But you wouldn't actually do any drawing on the actual model itself through the layout, because it's not going to be connected to the actual drawing. So if I was to draw some tree protections around these trees, I produce a nice little line there. I'm pleased with myself. It's not actually on this drawing. Nothing's appeared here. It's laid over the drawing. And it's a very dangerous thing to do, because if I decide, I just need to adjust this view slightly and perhaps scale it a bit, I've now got to change all these entities, readjust them, mess about. So we don't draw on paper space, it's just for creating your sheet layout. And that's all I'm going to discuss about it at this time, because that's going to be a video in itself. The layout or paper space views, they can be called either. But what I'm trying to sort of get across is that when you get given a drawing, if it's been saved with a layout set, it will come to you with that layout set, and you just need to select model before you start fiddling about with it. So model space, it is just a massive canvas where you can draw just about anything from a paperclip to a town centre. Everything that's put on it is located with coordinates. If I draw a circle, you've got the X and Y position on this canvas. These are the axes. So this circle is 2,500 units from the origin. So it's 2,500 units from that point there along the x-axis, and 1977 from the y-axis. If one of these values was negative, if I put a minus in there, my circle has disappeared because it's now come down here, because it's now a minus. So it's minus from the 0, origin. But we don't draw in absolute values because we've been supplied a drawing, or you should have been, so we don't actually need to draw anything from scratch. And because we're using AutoCAD to show a site plan, it's rather convenient that the y-axis can be the north-south axis and the x the east and west. Of course, the drawing may be rotated. You may have been given it rotated. It may have north sticking over here somewhere, but generally 95% of the time a topographic survey will come to you north-south and east-west along the horizontal. So we can actually use the Ordnance Survey grid, because that also uses the same axes. They can actually set the topo coordinates to the Ordnance Survey coordinates, and that can be very handy for overlaying GIS stuff from DEFRA and OS. As an example, if I just load in my Essex site, this is an old site from many years ago, and it's been fixed to the OS grid, which most topos are, the better ones are, and you can see the grid up here, which means every item is fixed to the OS grid. If I also load in, this is a free drawing from I think it's OS or it's DEFRA, one of the sites, and it's the southern half of the UK, and it's packed with just basic information. The roads are very rough, they've all been straightened, and it only indicates the sort of centre line, but you know, they're a few metres out. But it's quite interesting because you've got the it shows the wind farms all around England. I'm just going to remove all the text just to make it easier to use. So I'm just going to select text, select all, and it's going to select all the text for me. It's selected 38,500 items. I'm going to hit delete. And I can now grab my Essex site. I'll right click, copy with base point, and I can use 0, as the origin because it's on the OS grid. Go over to here, right click, paste as a block so it's all together, and I'll type in 0. And I saw a little tiny flash here where it sort of went in, so I'm zooming into Essex, and there's our site sitting on the UK map. And you can see the lack of accuracy on the OS on this large OS map, this junction here should sort of be fitting this road here, this road centre, and this road here should be in line with this one on the actual topo. But it's not bad, and it just sort of illustrates the coordinate system. You've got the OS grid here, and the origin is west of the Scilly Isles somewhere down here. So I should just close these because that is a large drawing and it uses an awful lot of memory. I will try and remember to put the links for it in the description so you can actually download that large OS site. So before we go any further, I just want to remind you about the properties. If you don't know how to set them, just click the view and click properties and dock it onto the side, because we're now going to talk about the Z axes and really need to see what's going on over there. Z axis is the heights. Now that's used in 3D work mainly, so we don't really care about it, but it can cause problems if it has been used. If entities have got Z values and you go to measure things and plot things and whatever, you need to be aware of the Z axis in case you start meeting these situations. So we're going to very quickly talk about it and start by over here. I'm just going to plot a circle and then draw another circle inside that circle, locked onto its center, and both circles are 0 height or 0 on the Z axis, but I'm going to set this one to, let's say, 25. So this circle is 25 meters high and this is at 0, and I'll just actually make that radius 15 and this one 30. Okay, so I've got two circles, one 25 meters higher than the other, and of course they look no different because we're looking down from above and the Z axis is coming straight towards us. If we go to an isometric view and you look at our UCS now, the Z, you can see the Z pointing up this way, and you can see our two circles, one above the other. If I go back to top and draw a line, and I'm going to lock it to the center of the bottom circle and lock it to the center of the top circle. I've drawn a line there, and I can prove that because I've got three entities and my line is there. But because I've drawn the line vertically, because they both have the same x coordinates, they both have the same y coordinates, but the z coordinates are different. It's basically a vertical line and we're looking at one end of it, so we can only see a tiny little dot. If I go back to my isometric, you can see the line from the center of that circle to the center of that. And that's because I locked each end onto an entity which had a z value, and it took that value onto itself. If I go back to the top, and this circle is 15 meters in radius and this one is 30 meters, then it makes sense that the distance from there to there is 15 meters. So let's measure it. And indeed, look, it's nearly 30, but I'll just click that. And the answer has come out as 29 meters. Yet I know that that should be 15 because that radius is 15 and that radius is 30 and 15 from 30 is 15, so why am I getting 29 meters? It doesn't make any sense at all, does it? But it does, because if we go to the front view, we are essentially measuring from that point to that point at an angle. And this is important to remember, because when you come to drawing things and measuring things and you've got 3D Z values, they can really throw you out. Basically what I was doing was measuring from there to there, which should be 15, but because I was locking onto this line, it was pulling it down and measuring like that. If I go back to my top view, and go to draw a circle and lock it onto there, because it's now asking for the radius, if I lock the circle onto this one, it's going to take on that longer value. If I lock it there, everything's fine. It's nearly 15 because I'm not quite on the line, but if I lock it onto the line, poof, it's taken on the 29 meter angled distance and use that as a radius. So if you have a drawing and you're doing things and these sort of strange things start happening, and they won't just happen with circles, they can happen with lines and all sorts of things, you can think back and think, have I got any Z values here which I need to get rid of? And you can get rid of them by actually, if you go to the quick properties and say select all the circles, and then you can set all the Z values to 0. And if we look from the front now, everything's flat. Of course I didn't do the lines, I just did the circles. You'd have to do the same with the lines. So let's just delete those and go back to my top view. So let's talk about units. So when you draw a circle and you put in 10, you are drawing that with a radius of 10 AutoCAD units. It doesn't know if it's a millimeter, a meter, a foot, an inch, or anything. You have to work out what your drawing is, and the easiest way to do that is to simply measure something. For instance, like a road, you would expect a road to be 4, 5, 6, 7 meters wide. So you would just measure it and you can see it's 6.7. Now 6.7, it can't be millimeters, because you can't have a road 6.7 millimeters wide, so it must be meters. And if I load in, I've got this drawing in millimeters. So I measure, say, the road width, and it's 6,784. So that has to be millimeters. You can't have a road over 6 kilometers wide. So it's got to be millimeters, and this one is in meters. And it's important to know this, because when you come to start drawing things, for instance, if I'm in the millimeters drawing and I want to draw a circle around this tree with a radius of 6 meters, I put in 6 and the circle is nowhere to be seen because it's this tiny little dot in the middle, because I didn't check what drawing I'm using. This drawing's in millimeters and I need to make that 6,000. And I've got my 6 meter circle. Now you can control what AutoCAD displays on its readouts, on its properties, etc. by typing in units. and say select architectural. So if I now click on my 6,000mm circle, I've got 203,977 feet on the X position. I've got a radius of 500 feet because 6,000 inches divided by 12 inches equals 500 feet. So I'm going to now talk about snap settings. I'm back with my meters drawing. I've got rid of the millimeters. And my snap settings are always set to nearest and intersection because these are the two I most use and are the most useful. They enable me to lock onto lines and intersections like a corner or the nearest position on a line. If I want to use an extra one, I just click it from my toolbar here on the left, like a center of a circle, and it locks onto that. I can go vertically or 90 degrees to a line, midpoint to a line, whichever line you choose, and it will go to the midpoint of it. And these are actually the ones you'll probably mostly use. And of course you can just go freehand. And if you want to go freehand close and it keeps trying to lock and you don't want it to lock, zoom in a bit or just switch your snap settings off. And you can go close and then you can switch them back on again. You can also, if you don't want to use a little sidebar like I do, you can just shift right click and they'll all come up for you and you can just pick them off as you need them. So if you wish to have this toolbar showing as I have, you need to just click this little thing up here, show menu bar, tools, toolbars, and then click the one you wish. There's absolutely loads of them, and you just click object snap, it'll appear, grab it and dock it to where you like. You can go anywhere you wish to put it. I have mine on there permanently. And the reason we use snap settings is because freehand is sloppy. If I'm just going to hide that menu bar again. If my snap settings are off and I just want to draw a line from this corner of the house, I'll just stick it there and come over there, and I just want to touch this fence here, so doof, there you go. If I zoom in now, you can see how I've missed it. And I've missed this one as well. But if I had my snap settings active, I can grab that and lock it properly to the corner. And grab that and actually use its own line as a snap point now. It's accurate, nice work, and that's what you should strive to do really. And finally, just for this little first video, let's just talk about the ortho mode switch. It's very handy. It's if you're like drawing a line, say, and you switch ortho on, it forces that line along the horizontal or vertical, or the X and Y axis if you like, because they could be pointing somewhere else. And it can be very handy in certain situations, especially when you're actually in paper space and you know you've maybe got a key and you just want to shift it up a bit but I don't want to move it the other direction. You know, you'd switch that on, move, and it's locked to that axis or that axis, so you just adjust it how you wish. So that's it for this video. I hope it was useful. It should set us up nicely for the next one, which will be covering the drawing functions, the main ones that we're going to need. We're not going to cover any that you're unlikely to ever use. You can check those out yourself. So see you on the next one. Thank you very much.